Right. Accessing elements, we can do it two ways. So let's start with that one. First of all, let's print X, and then getting third row, fourth column, we set like this: print X, third row the index is 2, fourth row the index is 3. So this is I think that this is the best way to access it, but you can do iteratively. Like, first of all, you can get the third row like this: print X2. You can get the third row like this, which will get the third row. This is 1. Then within that you can get the fourth column. So that means index is 3. This is also could be used, but the preferred method is this, which I missed last time. So make a note of that. But commonly, row and a column would be the easiest way to access. Right. Now that we have discussed of this, there's a very important thing when you are getting a submatrix, part of the data, so which I would like to discuss. Right. So I'm going to use the same X. So maybe I'll copy paste from here so that it will be available in a separate code window. Right. Right. So I'm going to keep it here. Right. Now if I say like this, give me an answer. So I want to create a new matrix, submatrix like this. Can you give me the meaning of this? Right? Without printing, can you tell me what is Y actually? Yes? What is Y? Now you should understand the slicing. When you say 1 to 3, what it means? Yes, second row. So 1, 3 means 1, 2, right? 1, 2 means second row and third row and second column and third column intersects each other, which means what is output? If this is X, 6, 7, 10, 11, right? Okay. So this is first thing you need to understand. So I hope now it is clear for you. We get this. Now let me do something like this. Okay, I print Y. So I'm going to say something like this. What do you expect? So after the first print Y statement, when I say Y, colon, comma, colon, what it means? Colon means everything, all the rows and all the columns we are going to set to 0. Now when you print Y, what do you get? You have zeros. And when you get X, what do you get? Same X or the different X? So maybe I can print here the X first. Yes. So our original X and what we are going to print at the end, are they the same or the different? Is it same? Okay. Just run and observe. Are they same? Yes. This is our original X. This is our Y. We set all the elements to 0. What happened to X? It has changed. So what it means? what it means. Yes, what it means. Our x has changed, right? Our x has changed. So we have x, we got a part of x as y, we change y, and that changed x as well. You got my point? So remember, if you get a data set, get a part of it, if you change it, what will happen? It will change the original as well. So remember, if you are putting in a matrix form NumPy array, you have to be very careful about this. So make a note of that. This will be the view of x. So we are going to say y is a view of x. In databases you might come across a view. View meaning your original data, right? So which means if you change y, what will happen? If you change y, what will happen? It will change your x as well. So the idea is, if you want to change, you have to take a copy of it. Right? The way that we did it here is we are taking a submatrix. But submatrix will represent a view of x, which means if you change, it will reflect in your original matrix as well. So the trick is, if you want to avoid this, we have to make a copy, which I will explain how to do that. So let's try this code, and then I will explain how to make a copy of this.
Don't confuse with the databases. But the view is, the idea is like you are viewing, it's a separate view. But the thing is, that view actually represents your actual data. So that's what I want to mention it here as well. So what happens here, we are taking part of it, but it will actually the view of the original, which means if you change it, it will change the original as well. So the idea is, if you are getting a data set, part of the data to be manipulated, you should take a copy of it. Now those who have some computing background, if you want to know more, read the book, because in the memory it represents the same. That's the reason why it is happening.
So why is the copy of x?
Not the copy, that's where the problem is. It refers the same memory locations. So for example in Python, since you have asked, so in Python, this is, if you have some knowledge in programming, when you say A is A, when you say B is A, in Python memory, so in memory what happens, when you say A 10, it will allocate a memory to store 10, and we store 10 there, and we have a memory reference which will refer to the location. So when we say B is A, it will not create a new one. So B is also refer the same memory location, because what we say is B is equal to A. So same goes here as well. So it will refer the same memory location, which means when you update, it will update the, right? No, I mean like, now in this particular case, if you say A is 20, then it will store in separate. This is separate. Right? But when it comes to matrices, so it will update the memory. Matrices. So when you are creating matrices, you have to be very careful. So that's why we said it's a view of X. Right. If you don't want to affect your original X, if you don't want to keep your original as it is, so the change would be
I'm going to copy paste the same code. Have you finished up to this point? Yes, you need more time. Just put it here dot copy. So here you can put dot copy, right, as a method. So you can say here we have y equals x 1 to 3 1 to 3 dot copy, which will get a copy of it. Then working with the copy will not harm our original matrix. NP is not defined then අපි අර people need to import එක දාන්න. ඒක load වෙලා නැතුව ඒක. If you are getting error about NP, I'm assuming that we have already import this. Import numpy as NP. That should be there. We have earlier we have all that like if you get any error, just let me know, because that's the first thing. Done? Right. So I'm going to make a copy of this. So if you want to change your data without affecting your original, what you should do is you make a copy of it. So with the copy method, right? So now this will be a copy of x. So if you do like this time you will notice this will not affect your original x. Done? Finished? Okay, next one. Again, very important idea I want to discuss. Any questions on this one? When you are copying matrices, you have to be very careful. If you just take a part of it or even a copy of it, so you will get the view. So make sure that you use a copy method. Right, next idea. This idea is called fancy indexing, or we call Boolean indexing. Right. Now fancy indexing or Boolean indexing, indexing means, we remember when we have a list, we use index to access individual items. Now this calls fancy indexing. We are going to access elements using some conditions, right? So let's start like this. Let me create a vector using np dot linspace, linear space vector going from 0 to 1 and with 11 points. Can one of you tell me like what are the values we will get between 0 to 1 if you have 11? Yes? You should be getting 0, 0.1, 0.2 up to 1. Okay? Now let's say we want to get only the values greater than 0.5. We want to get values greater than 0.5, right? That's the requirement. So simply what we could do, we can check this. This is simple check. I'm checking whether A is 0.5. Although we say A, this check will, the checking the value whether it's greater than 0.5, right, done it individual level. So when you run this, you will notice what will happen. For each value, we will get true or false depend on whether the condition is true or false. So for example, first value is 0. So 0 is not greater than or greater than 0.5, it's false. You see? And the last 5 elements we get true, that means 0.6, 7, 8, 9 and 1, isn't it? So if you want to keep only those values, simply we can use fancy indexing, which means like this. We can say A within square brackets, we can have this inequality like the check 0.5. So what happens now, it applies to all the elements individually and it will print only the satisfied ones, which will output will be look like this. So given a data, when you want to filter out, this technique is very easy, which I am going to use for graphics a lot, and I will show you. Like for example, let's say we have a data set, we have 3 different classes and we want to plot them in 3 different colors. When you want to filter out the data points, I can say that okay, class 1 we can check using this idea. So it will give us only the point relevant to class 1, class 2, class 3 separately, and then we can plot. So for data filtering, this is very easy use of fancy indexing. Right. Another idea, reshaping. Now reshaping is another idea which we are going to make use of a lot. For example, images. Let's say you are going to use images, but when you want to learn from images, images are 2D, which sometimes we have to put into one single array. So that means the 2D array, we want to make it 1D array. Same, we can go other way around as well. We can get 1D array and make it to 2D array. So the trick that I am going to use to generate something like this. Now for example, in here we have manually typed, which we don't have to do. Because if you can get a 1D array with numbers from 1 to 16, the next technique could be used to make it a matrix. So the first exercise I want you to give is, give me a command to create a vector which has numbers from 1 to 16. Shall we start? I want you to create. So the next idea that I would like to discuss is reshaping. Numbers from 1 to 16. What is the command? Yes? Yes? Vector? Which command you have used? Yes, you can use arrange or you can use linspace, whatever you like you can use. So let me use this. So I will say print np dot arrange starting from 1 to 16, then 1 comma 17 would do the job, right? Yes. Now let's use a reshape. So let's say if you want to have a 4 by 4 matrix from this, simply what you can do is you can use dot reshape and you will say, okay, I need a 4 by 4 matrix using these elements, which will give you a matrix like this. Okay, can you create a matrix like this? And here we give you the command 0, 1, 2, 3, 4, 5, 6, 7, 8. Yes, can you give me the command to create a matrix using reshape? So let me say we have matrix A 0, 1, 2, 3, 4, 5, 6, 7, 8. We have B 1, 3, 5, 7, 9, 11, 13, 15, 17. C it's 2, 4, 6, 8, 10, 12, 14, 16, 18. Yes, can you create these 4 matrices? Any questions on this? So the trick that I have used is I first generate the elements and then use reshape to make the shape of the matrix. So if I want to create A, what should I type? What is the code? A we have to say np dot range 0, 9 dot reshape 3, 3 would do the job, right? Print A. So now B and B dot arrange 1, 18, 2, okay, dot reshape 3, 3, okay. So let's print B. One, 3, 5, 7, 9. Okay, that's good. Yes. Third one. Range 2 comma, okay, 19 2 dot reshape 3 comma 3 D. What is the starting value? 8. End value? -1. Step? Step? Again -1. Dot reshape 3 comma 3. You see, vector generations are easy by using the knowledge that we have gained from our previous steps. So the computers you are getting through the MS, because I see like all of the 3 computers are looks the same, and here also looks the same. So yours are HPs and yours are that's a HP. Sorry? You said very good. Where in our case there's no now in your code you have type print here. So what happens when you say print, it will print it, but nothing to assign to A, so therefore A will be none. So when you say printing, it says none. Nothing to assign, right? When you say print, it will print it to the output, nothing to assign to it. So that's it. Right. Is it too much now? Overloaded? Okay. Let me know when you feel that it's too much. Okay.